I just realized that I was on mute. Let's start over. That happens, that's live. Hi, everyone. It's Friday, 4 p.m. here in Berlin. My name is Jurasi. I'm a software engineer, and I've been doing telemetry systems since 2015. And for a couple of years now, I think 3 years now, I have this side project of mine called Dose de Telemetria in Portuguese, where I bring to every Friday for half an hour, perhaps a little bit more, a little bit less, some content about open telemetry, about monitoring, observability, but more specifically open telemetry. That's what I've been doing since 2019, and in this area here, in this channel here, or at least the one in Portuguese for 3 years, I've been bringing you content in Portuguese, deep technical content and up-to-date content. And a couple of months ago, I created this spin-off, the telemetry drops spin-off. And I'm trying to follow the same philosophy here, right? So I just open a live stream, I open my camera for half an hour or 1 hour, not 1 hour, so half an hour, 45 minutes at most, where we talk about the same topics. And the main difference is we do talk about up-to-date information about open telemetry specifically, or more importantly, but also things around observability. A couple of weeks ago, we on telemetry drops, we talked to a few people about what do we need to do to observe AI things, or like AI agents or LLM calls and things like that. And today we're going to do the opposite. We are going to talk about what are the cool things we can do with LLMs when we have telemetry data. And let's see what are the things that we should be doing more, and what are the things that we are looking forward to doing in the future as well. What do we see as the future? What is the workflow for people working with observability nowadays? So this project here, every couple of weeks we have a live stream. So every other week we have in English, and every other week we have it in Portuguese. So people who speak Portuguese are at advantage here, because you can follow in Portuguese and English. So that's a good cue for you to learn Portuguese as well, perhaps. Anyway, I would like to talk just a little bit about open telemetry before I call my guests today. We have the open telemetry governance elections coming up soon. To go there, if you are a member of standing, meaning if you have more than 20 contributions to open telemetry, go there and vote. Take a look at the candidates and pick the people that you think are going to be best for the project. Go there. It doesn't have to be me. I'm a candidate, but it doesn't have to be me. Pick the best candidates for you, right? So take a look there, look at the proposals, and really, the community depends on you. So go and take a look, see what are the proposals, see what people have been done in the past for the community, and pick wisely your candidates. That said, we have a few things also happening around open telemetry. So we have KubeCon coming up in a couple of weeks' time. I'm going to be there in Atlanta, have a couple of talks there. And the CFP for Observability Day and for KubeCon Amsterdam for next year, they're open. So make sure to send your proposals. Actually, they are not open anymore. I think they just closed, actually. So, but I think you can already register for those events. Co-located days are still open. So Jamie, one of our guests is telling me that co-located is still open. So Observability Day is still open. You can still send your proposals there. Talking about Jamie, so let me call the first guest for today. Let me open the. Oh, come on. Click there. There you go. Hey, Jamie, how are you doing?
Hi, Jurasi. How are you doing?
Very good. Jamie, do you want to introduce yourself? So who are you?
Yeah. So hi, I'm Jamie Danielson. I'm a software engineer at Honeycomb. The last few years, I've been working in OpenTelemetry. I'm a maintainer on OpenTelemetry JavaScript. And for the last few months, I've been working on some of Honeycomb's AI features. So I'm excited to talk about kind of an intersection of these two things between OpenTelemetry and AI.
Nice, wonderful. Yeah. And the second guest for today is Nico. So Nico, hi, welcome.
Hello. Hey, Jamie. Hey, Jurasi. Hey, everybody who's watching. I'm Nico, or Nicolas. I'm working at OllyGarden as a software/data engineer. That means I'm writing code with a focus on AI, and I'm taking care of like all the AI integrations we build into our product here. In the past, I also used to work more on the DevOps side. So that means I know how to operate the systems, how to do all the maintenance, about keeping track of everything, but also about writing the code. And yeah, I'm happy to be here today.
Cool, nice. So I'm not here as OllyGarden, right? So let's just make it clear. Nico is here as OllyGarden because I know that he's doing very cool stuff there. I also know that Jamie's doing very cool stuff with AI nowadays. And even though I work with Nico at OllyGarden, I'm not here as OllyGarden. I'm really telemetry drops here. Just make it clear to everybody. Cool. All right. So Jamie, let's start with you. I have a question. So for us to start the discussion, and people who are watching us, leave your questions here, leave your comments here. We are really live, so you can have you can leave your questions and have Jamie or Nicola answer them live for you. But Jamie, I was mentioning earlier to Nico that it's such a we live in such a strange state right now, because last year, when I look at myself last year, I was not using the same tools I'm using today. I could never have guessed last year, like October 2024, I could never guess that I would be using some crazy tools to look at my telemetry and tell me things that I don't know. What are the things that you've been using nowadays that is telling you things that you don't know about your telemetry? What are the cool tricks that you've learned since, I don't know, since 1 year?
Yeah, sure. You make a really good point. I think the explosion of tools and how good things have gotten just during this year is really remarkable. And I don't know if anyone really quite saw that coming. We've been talking about AI and LLMs and all of this for a while, but it's really started to hit mainstream, and people have started to figure out how to really specialize with those tools and how to really get information they're looking for. So one of the things that's really neat is that we can use these tools to go over large amounts of data. So that's always a thing that computers have been better at than humans, right? Is to be able to sift through large amounts of data and do something with it. And so what we've found is that if we have telemetry data that we are able to send, and especially using open telemetry, which is, again, open standard, so it's recognized in all sorts of different places, different backends, and there's lots of documentation on it. By having this standardized sort of telemetry that we can send along, we can then use LLMs to make sense of that data, to sift through it and find things that maybe would take us a little bit longer to find. Even in some of the best backends that have really good, querying capabilities, there's still so much that you can get so much faster when you're using these LLMs for things like that.
So do you think that there is still a lot of, at the beginning of the year, there was a lot of hype, right? There were a lot of people saying, oh, look at this one thing that I'm doing here. And that was a really nice proof of concept. But when you tried to use on a daily basis, it would just fail. Do you think we are at a point where we can actually be productive with the tools that we have at hand? Or do you think we're not there yet?
I think both can be true in different situations. So one of the biggest keys that I found, and others have obviously talked about this too, is that the more broad that you go, the wider your range of topics or things you're trying to solve, the less effective your tools are going to be. So if you're able to have something that really specializes in something, so if you're able to write something that is very specifically looking at open telemetry and telemetry data, it's going to be a lot more effective than if you use something really vague, like a generic question into ChatGPT or something. Anytime you can give a little bit more specific context and use some prompt engineering to be as specialized as possible, depending on what you're working on, you're going to have a lot more success in whatever you're trying to do.
Nico, what are your cool tricks? What are the things that you've been doing that are really cool that you would never have guessed that you'd be doing this year?
There are actually a couple of things. Yeah, so maybe I can just start with like the first thing which I found really amazing, and I think it was when the first MCP servers came out, and I was hooking that MCP server into my assistant, and I was just prompting a question like, "Tell me what is going on in that dashboard," and I didn't look at the dashboard. I was just typing in that query, and then suddenly an AI was responding to myself, "Hey, your response time is going up right now," or "everything is good." And just that human interaction, or that human interaction that feels like a human interaction about the data you're receiving, and if potentially something goes wrong or not, that felt like crazy. And then if you even go one step further, you have maybe an incident, maybe something is going wrong, and you ask, "Hey, can you please perform a root cause analysis for myself?" And then it comes up, "Okay, I noticed we have an increased response time there. This could lead to consequences in that related service, which is connected to maybe that database." And getting that back in the chat conversation like style, that really impressed me at the beginning. I mean, now it's kind of part of the workflow, but when I first stumbled over that, that was really impressive.
And what is your success rate when it comes to like, is this agent telling me the truth? Like, can I trust that data? And then when you look at the data, it is real. Like, I guess the question is, how much hallucination are you seeing on a daily basis?
That's a good question. So I had cases where I was really surprised, and then I had cases where I got a response, and the LLM was very, very convincing, and it told me, "Hey, that's the root cause," but it wasn't related to the actual issue at all. So it's still definitely not 100% perfect. But what I personally found is working very good. If you, for example, take an OpenTelemetry trace, you can export that also as a JSON file. So you have like this JSON structure of that trace. And I saw very, very good results if you take that JSON body and feed it to an LLM to analyze that. And then it tells you things which you would never see as a look at just as the JSON file. And that worked very well for myself. But in general, it's hard to say, okay, it's always working or not working. It's tricky.
You are absolutely right. Jamie, do you think that the quality of the data that we have right now makes it easier or harder? I think I asked this question before to you, so I kind of know the answer, I suppose. But do you think the quality of the data that we are collecting from our systems make it easier or harder for AIs to digest? Like, is it better to have more data, or is it better to have, I don't know, less data? Let's put it this way.
I think the question is less about how much data is going in,
Right.
and unless by having more of a certain type of data, there's a pattern that emerges. So that's one thing that LLMs are especially good at, is identifying patterns and working with that. And so to your point there, what makes sense is the LLM is going to make sense of what it has. And so if it's getting a lot of maybe jumbled data, so occasionally you'll see someone has accidentally instrumented something incorrectly, where maybe these attribute names for something don't really make a lot of sense, and they don't really line up with anything. It's going to be a lot harder for an LLM, just like it would be for a human, to figure out what's actually going on there. What can be nice is over time, when you start seeing, I guess, sort of what Nico pointed to before, when you start seeing that you're getting some wrong answers around something, you start seeing maybe this is where I have an opportunity to clean up my instrumentation. So if I have, for example, an LLM telling me that this one trace is problematic, and I look at it and realize it's actually not, it's just because I have a misleading attribute name or something like that, I know that I can go into my code then and fix it, and then see if I get a different response the next time around. So it's definitely sort of the idea of the cleaner your data, the better it is, the easier time it's going to have working with it and giving you the results that you're looking for. But it also doesn't have to be big bang all at once. Everything has to be perfect. It's an iterative process, so that over time it becomes more and more effective, I would say. And generally speaking, I would say that the LLMs, especially when you're hooked up to MCP servers for different things, they give you really good jumping off points or maybe different perspectives you might not have thought of. So even if something does turn out to not be entirely correct, it might give you an idea of a different way of working with it and maybe asking a follow-up question that gets you closer to the answer you're looking for.
Mm-hmm.
And if I could add maybe one thing here, I totally agree with what Jamie said. And often I think it's also sometimes the small details which matter. For example, one scenario which I had in the past, I was working on a trace and we had the service.name attribute, which was describing the actual microservice at OllyGarden, which was processing telemetry data or which was producing the telemetry data. But we also had an attribute which was service_name, which was the service. So the service which was belonging to the telemetry. So not the service which was producing the telemetry, but like the metadata about the telemetry we've been processing. And that small difference in the trace really confused the LLMs. So it was going crazy about, okay, I have this service.name and service_name, and it's two completely different things. And it was mixing that up and giving me wrong answers about that.
I mean, I guess it is not confusing to LLMs only. I mean, it is confusing to me as well. Like if I see the same attribute, the same name with different semantics for the same name, that's confusing. Right?
Yeah.
And I guess this is actually a something that I saw the other day in a different context, that AI or LLMs, they're actually uncanny right now because they are so similar to humans in the way that they operate. Like the instructions that we give to LLMs are like the instructions that we should be giving to our kids. Like they should be very precise, or they should be kind of like not confusing, or they have to have the context like around the information. But anyway, I guess the next question that I wanted to make is, we all have our preferred signals. I'm a tracing person myself, but I know people who are logging people. And do you think that that new way of doing things can make it easier to work with all of the signals at once, or to correlate signals and to do things that you don't know? Perhaps question Jamie.
Yeah, I think one of the greatest things about these tools now, which I think Nico sort of talked about earlier too, is the idea that you don't have to know as much of the details about either your data or how it's stored or how it's being generated even, because you can use the LLM will help sort through that sort of thing. So I'm thinking of when we were trying to troubleshoot an issue with one of our new features. We were, working with our own LLM, trying to figure out what's going on, asking our using our MCP server to look at the data itself. And it was nice to not have to say, this is going to be a log and this is going to be a trace, and go try to sort those out. It was more of, here's where I'm looking around this sort of time frame, and it picks through all the data. It doesn't really matter if it's a log or a trace or a metric or something else, because it's just data at the end of the day. So that, I think, makes it a little bit easier. The main thing is going to still be, traces are good for durations and things like that. But when it comes to the actual data that you're getting from your system, it doesn't matter so much how that's coming through, as long as it's coming through.
Nico?
Yeah, so I'm also a traces person. So actually tracing, or when I saw my first OpenTelemetry trace, that was like the point where I fall in love with OpenTelemetry. But another signal which I found very useful in combination with LLMs are profiles. So one day, I think one of the first things I did here at OllyGarden, I was writing a service which is processing a lot of logs. And I created benchmarks for that service, and I noticed, oh, I have a lot of allocations in that service. And then I created a benchmark, and I exported the pprof profile, so the service was written in Go. I exported that profile, and I took it and gave it to Claude to have a look at the profile. And Claude was not only able to exactly tell me which function is causing all those allocations, it was even able, because it also had the context of the source code, to tell me, hey, that's because of this other function, which is calling that too often maybe. And you could write the code instead in this and that way. And with that, you can save some allocations. And then I applied the fix. My service was working the same way like before, everything as expected, but with way less allocations. And just by giving a p-profile to an LLM, and it told me like, what's the fix for that? That was, wow, that was impressive, honestly.
Yeah. Yeah, I profiling is what I had in mind when I asked the question. I didn't want to mention profiling because I want to vibe question you all, like
Leading
providing
question,
as
you don't
little
want
context.
those.
But I went into a similar situation in the past where I was looking at the memory for our ingestion service, and I had concerns about memory consumption there. So I took a 2-hour window period from our profiling, the profiling tool that we use, and I got like a 2-hour window, download the pprof, different shapes, like I don't know how they call it, the profiles, right? So the heap and the stack in allocations and in the actual size, use size, and so on. And I fed that all into Claude as well, I think back then, or Cursor even, and it just told me like, oh, this is where you should fix, and I applied the fix that it proposed. Went to pick up my kid at school, and then a couple of hours later, I got another 2-window profile, and then compared and asked a Cursor or Claude or whatever to compare both, and then it proved I was absolutely right. I mean, the fix is there. It is working. And I had other cases where it just said, no, it's not, it's not proving the theory. So it is, so the fix didn't actually fix the situation. So I had both cases there. So in one, it hallucinated, but then it found out that, oh, it didn't actually help, right? So yeah, and I don't know profiling at all, right? So that was one of my first interactions with profiling.
That's one of the coolest things, just that statement right there. I don't know profiling at all, but I was able to just get this piece of data, get this P profile, put it into Claude, and you get answers. So it's like over time in tech and computing, we keep building these abstractions for things that we don't always need to know as much about. Now, generally, it is good to get to the point where you're getting deeper and understanding more of how these things work. But there are definitely times where the abstraction is okay, right? There's certain things I don't have to worry about with how my code is working under the hood because I have this abstraction. People use React, and so they know a little bit less about JavaScript. They should get to the point that they know the foundations, but sometimes just at that higher level is okay. I think the same thing is true here. If we, you don't need to know all the details about profiling just yet right up front on day one. You can start with, here, help me get some answers here. And then over time, you can get deeper into that as it makes sense to get past that level of abstraction.
Do you think that's going to be the case for most people, or do you think it's going to be the case for enough people? Like we have abstractions around the Linux kernel, right, or the kernels. Not everybody knows how a kernel works, and that's fine, I suppose. But still, we need people who know about the kernels. Right? So, what about for instrumentation? Do you think it is something that most people are eventually gonna learn, or is it something that people are eventually just not care about?
If I could maybe jump, sorry.
No, go ahead.
Okay, so if I maybe could jump in here, because I have a good example which I had just this week. At OllyGarden, we have a lot of services which are written in Go, and most of them are well instrumented. And last week, I was writing a service in Python, and I knew, okay, I'm consuming some messages where I want to propagate the trace context to another service. I knew what I wanted to do, but I didn't know exactly how I can do that in Python. So I knew the concepts, but I didn't know, okay, I need to call the function which is named like this. And what I did then was I told Claude to read the OpenTelemetry Python SDK code so that it has all the syntax in mind. And then I asked, and then I gave it the code snippet from Go, which was properly instrumented. And I told it, please replicate the same in Python following the syntax from the Python SDK. And I think it one-shotted that whole thing which I needed there, and I was able to propagate the context to another service. And that really saved me a lot of time, because I knew the concept about that, but I didn't need to go deeper into the source code and figure out, okay, what was the exact functioning to do what I wanted to do. And I think that touches a bit what you mentioned, that we have kind of an additional abstraction layer, which makes it easier for us if we, for example, switch languages to do the same things we already know the concepts about, but in a different language.
Yeah, I think that's a really great example. I like that a lot, especially, you touch on an important word there. I think concepts, like knowing what you are trying to do. So many people think of writing code as just writing code, right? But you're not writing code just for the sake of it. You're solving a problem. You're trying to get to the bottom of something. You're trying to create something, whatever that may be. So it's never just about, I'm just going to open an editor and start typing. It's never just, Claude, go write me a thing. It's, okay, I know that I want to propagate context from this service to this service. I know that here's how it's done in these different languages. How do I go about doing that? And so the difference there is, instead of you going into those details and having to learn all of that Python at that moment, you at least know the underlying concept and foundation of what you're trying to do. And that's really the more important part anyway, right? The code is just the result of that, but you already know the problem that you're trying to solve. And I think that's one of the most valuable things you can do.
Yeah. I feel like eventually we're gonna have a problem there where the tooling around the solution is so good that people are not don't feel the pressure to go and learn the actual, like, the basics and then the foundational, to have the foundational knowledge, and it might end up causing unwanted problems in the future. For instance, people already today, they have trouble understanding OpenTelemetry. This is a fact, right? I mean, it's so many things that we have at OpenTelemetry that it's hard for people to wrap their heads around. Like, is OpenTelemetry the collector, or is it the protocol, or is it the APIs and SDKs, or is it everything, or is it nothing at all? And I think that people that are trying to get started, they have a hard time right now. And then we provide an easy button, right? Then we provide an easy solution. So, okay, so we know it's a lot. So use those auto instrumentation libraries right here. And you can get telemetry out of your application right now. And it's so easy. And then, because it is so easy, because there is an option, people don't feel the need to tell their developers, like, concretely, observability engineers configuring those auto instrumentation agents, they don't feel the need to go to their
Sorry.
I love that that ringing. So people, the observability engineers, they don't feel like they have the need to instruct their software engineers on how to properly instrument the things. So they end up not having quality instrumentation there. I guess my point is, if we end up in a situation where it's so easy to use that, people might not end up having that base knowledge. And then because it's so easy, then things go wrong. I don't know.
I would argue here maybe that this is not a problem which is caused by LLMs, but by us humans who operate or who use the LLMs. Because, in fact, I think in these days it's easier to get started with things like OpenTelemetry or with programming. It's easier than ever before. Earlier, you had to dig really deep into the documentation to understand what's going on. Now you can just copy the relevant snippet and put it in ChatGPT or somewhere else, and you get a good answer about what's happening. But as a result of that, because it's so much faster, we as humans, we tend to just do it quickly, because then it's done and then we can move on to the next thing. And I think that's the problem. So whenever we try to learn, for example, OpenTelemetry, it's important to not just do it quick and get something done as fast as possible, but to learn and understand the concepts of what's happening under the hood. And then once you understood that, then you can use LLMs to move around faster with OpenTelemetry. I think that's important.
Yeah, like I agree. I think this is not just a problem with OpenTelemetry, right? It's any kind of programming, anything you learn really. But so if I think back to the first time that I was trying to learn how to code, self-taught, didn't know where to start. And so there was this thing called Create React App, which was a very easy way to get a React app up and running immediately. So that was useful for me to start getting an idea of some of the concepts of how to have this website running. When I needed to go deeper, it was because there was an issue with maybe I wanted to change something with a linting rule, or I wanted to change the way that something was transpiled, whatever the thing was. And I realized I couldn't figure out how to do it there because there were so many layers of abstraction from where the actual compiling steps happened. So I had to dig deeper at that time to be able to understand more about what Create React App was doing. And after that, okay, I didn't need to use that anymore because now I had the foundation and now I could get a little more detailed. I think the same thing happens with OpenTelemetry, where you might start very simple with something like automatic instrumentation to get something there, and then it is really on you or the engineers or however that might be to then revisit that. It isn't a one and done and walk away. It is, okay, now that I have this, what do I do with this? Is this useful? Is there a lot of extra stuff that I'm not looking at that's costing me money? How can I change that? And you can still use Claude or whatever to try and figure that out, but you still have to dig into that and ask those questions of, even if it's something simple, is this useful? Look at my data, look at my telemetry and say, is this useful? And then you start learning over time, I think, okay, maybe this is better if I manually instrument this instead of the automatic library. But I'm able to get to that point because I see what comes out of the box first. I see what that might look like. And now I know how to tailor that instead of starting from nothing, maybe, and being unsure of how to move forward.
You just sparked a thought here that is it really us that should be looking at that data and making those decisions? Or should another AI be looking at that data instead of us and making those calls? Like, why does it have to be me looking at the telemetry that is coming out of my application and judging whether it is good or not?
Yeah, it doesn't have to be you.
Okay.
It could be you telling your LLM, or it could be, yes, if you have the tooling that is said ideally is going to be proactive and is going to, kind of let you know maybe this is off. One day in the future, it will change your code for you, right? And put up a PR and merge that in, and you're good to go. But in the meantime, it's definitely possible to be able to be proactive, looking at the data that's there and saying, here's some recommendations of how you might want to change the way that you're currently instrumenting your code.
I want to borrow your crystal ball because that makes so much sense.
Sounds nice, right?
But I think okay. So this is a good a good opportunity for me to ask you. Like, we started this conversation by me saying that last year in October 2024, I had no idea. Like, I could never imagine that we would be here doing so many cool things with AI, LLMs, and without telemetry. What are, like, let's get your crystal ball, and I suppose this, I hope this is the right term for that. But that you can imagine you are now in 2026 October, and you're looking back at 2025. What are the cool things that you are looking at that we cannot imagine right now? Like, what is the future for you? What could we be doing, or what are we going to be doing in the future that we're not doing today? Perhaps Nico first.
Yeah, so of course, the best possible scenario would be that, like, we have some observability in place, and then we see issues, and those issues get fixed automatically by some LLM model and raise the PRs. I don't think that will happen by next year. But one thing which I'm hoping a bit for, which is also a problem I experienced so many times throughout my career already, is kind of alert fatigue or notifications I get about observability data. So I think all of us know you have like this alert channel in Slack or in Teams or by email, and you get so many notifications and only a small fraction of them really matter. And I think we can, or there must be a way how we can do that better. Of course, there are best practices you can apply, but all of us know how that feels when you receive those unnecessary alerts and notifications. And to have maybe an AI in the background in place who's really good at deciding if that's really a problem or not, maybe launching some sub-agents to confirm if it's really a problem or not, I don't know. But having something deciding before it sends out the notifications and alerts to be able to better act when we have an incident, I think that would be really cool if we have that by next year.
Yeah, I think that's a definite area that is important to look at, especially we're always humans at the end of the day, at our computers helping make these things run. And as humans, alert fatigue is very real and can be a real problem. I think being able to have something that, like, today, usually you're saying, here's sort of what I expect to happen. So if something is slightly different than this, maybe the latency is higher, this or that, then I want an alert. But there's always the nuances there of it depends. Maybe if that problem happens once, it might not be a big deal. I don't need to be alerted on it. Maybe even if it happens a couple of times over an hour, that might be okay too. I only want to know when it's actually, statistically significant, where I'm having a large amount of errors or problems or spikes in latency. And so then going beyond that, I don't want to have to set what is my baseline, what is normal. I want to have the tools able to analyze the data that is coming through, determine what is normal over a period of time, and then be able to alert when there's a problem, so that at no point am I really involved except for now there's a problem and there's something to look at.
I think at the very beginning of this coding, like vibe coding, I think the origins of the terms are just like you provide as little context as possible. You provide just like the base idea and then let the coding agent do its work, follow its own vibe. I think that's the origin of the vibe coding thing. And then people took that into like, oh, if you're using Cloud Code, that's vibe coding. And I guess we are more professional nowadays than we were when people were doing vibe coding. Now there is this plan, a research plan, implement, or whatever the flow is there. And what you're telling me, Jamie, is that we are going to do like this. We're going to let the AI work on the plans that we are building, right? So we are, and correct me if I'm wrong, but wouldn't that then be a case or a situation where we just go back to the vibe kind of scenario and we say, I have a payment endpoint here. It needs to work. And that's it. Like, let the AI figure out what is work. It has to work. So no telling SLOs, no telling SLA, or perhaps SLAs, which is the external agreement. But then everything else could be figured out. Do you think that is like the direction?
I think that will be possible, but I think that's a long way out. The scenario I described was more related to, strictly looking at the data coming in and determining what is deviating from normal. I think one of the things that sometimes is forgotten with the AI hype is that humans are always going to be, the best at coming up with these creative, complex solutions. There's a lot that has to go into the thought process of how something should work. And so to me, it's less about, here, Claude, make me this endpoint, and more about, again, here's what I'm trying to solve. This is what the system is intended to do. And here's sort of how it should react in these different scenarios, and still planning through it. Like, even when I work with Claude, I don't do, here's a thing, give me code, and now I move on. I very much go into plan mode every single time and have more of a conversation back and forth of, let's start here. Tell me what you think about that. Let's iterate here. Let's change that. And that's how you're going to get better results. And I don't know, I think it's probably a long ways off before that's not the best way to do things. I think we're always going to have a bigger hand in that to be able to be successful and have good code at the end of it.
And maybe just as food for thought, but maybe in the future we would have something like observability specifications for our services, where we not only say, okay, alert me if something goes wrong, but we really spend some time to write in natural language what's the expectation, what shouldn't be the case, what's perhaps acceptable, and based on that, the system decides or evaluates if we actually have a problem. So that it's really like context engineering, but in terms of observability context. Maybe that's where the future will head to. I don't know, but it definitely won't solve the problem if we just tell an LLM, tell me if something is going on. That won't work. But who knows?
I know what I'm going to be doing in October 2026. I'm going to be looking at the telemetry of my hoverboard. So there's a question here from Claudio. So Claudio, if you were to set 2 questions on how to use AI securely on telemetry data, what those should be like? Perhaps Jamie first.
Yeah, I think there's a lot of this will depend on how you're doing this. One thing that I'm big on is if you're able to run something locally, meaning most of these tools that are out there have options for either we are going to use your data, we are going to train on it, we are going to send it to our databases, things like that. If you're dealing with telemetry, especially around customers or anything potentially with PII or something that you don't want sent along, that's probably not the solution that you want to take. There are things that you can run locally, or you can sometimes just turn off that setting of sending along that data. Again, most of these tools have that. Some of them you may have to pay for to be able to not have the company train on that data. But that's the number one thing I think that you would have in mind is don't send along data for training. And can I run this locally without having to send it across the wire?
One approach which I have seen here, that some persons are running like very small models locally who are not that powerful, but which are good enough to filter out PII data. And because you run them locally, it's more secure to use them. So you use that intermediate local LLM to potentially filter out sensitive data. And then you send it to a more powerful model to actually analyze the telemetry to see what's going on. And that could be another approach how to do it a bit more securely.
Yeah. So from what I'm seeing, most of the commercial usage of LLMs, like the Anthropics and the OpenAIs and the Googles and so on and so forth, if you're a business customer of them, then it's typically the case that they don't train on the data that they receive from you. They do train on your data if you have a private contract with them. Like if you have if you're not a business customer, then they might end up using your data. But for business customers, they typically don't. So I think in that area, I think it's not okay to send data to them, send PII data to them. But I think it's less of a problem if you send to the same providers on a private contract. But I do agree that local sandboxes and local LLMs are way safer in that area. But what are the other concerns about LLMs that we might take into account when feeding telemetry data into that? Jamie or Nico first now.
That's a good question. I don't have an answer for you right now to that question. So of course it's sensitive data, which is the biggest concern, like passwords, PII data. Yeah, I don't have an answer right now.
The only other thing I can think of is maybe what we touched on earlier is that, sometimes LLMs do hallucinate or give incorrect information. And so that could be something to consider depending on how it uses that data and how it interprets it. That's maybe the other main thing that I would have in mind.
Yeah, I think costs might be another one. Perhaps not security on its own, but I think it's the old thing. Like somebody forgot to turn off their AWS instance, and then suddenly they are bankrupt. Right? I think that's the meme, and I think the same here. Like, I didn't know better, so I sent all of the logs from the service to an LLM, and now I owe my life to OpenAI. So I think that's one concern that I would have. The other one would be what you do with the data that you're getting back from LLMs. Like if you're using telemetry to make decisions or to take actions, you want to make sure that the data that you're feeding into the action is actually sane. It's not a hallucination. If I'm opening a pull request based on telemetry data that I have, then I should have a way to validate that the initial assumption is sound. So perhaps a set of agents that can play against each other first, and then come up with a consensus, perhaps.
I think my immediate reaction to a lot of things is to be skeptical. And that has been useful in, don't make assumptions that everything is correct or 100% accurate. I kind of go in like, what is wrong with this thing? Sometimes I'll feed it into another LLM and say, what is wrong with this analysis? And I'll get some information. So I think, start with a skeptical eye, and that's going to help you out.
And as soon as you question and response from the LLM, you're anyway always absolutely right. So
Yep, you are absolutely right, Nico. All right, Jamie, Nicolas, thank you very, very much for joining me today. It was such a fun experience. Very nice having you here.
It was fun.
Thank you for having us.
So our next live stream is in a couple of weeks. I think we are having, I'm not ready to say who's going to be here in a couple of weeks' time, but hopefully we're going to talk about the isolation forest processor for OpenTelemetry. That's one that I don't know anything at all so far, so I'm really eager to learning more about the isolation forest processor for OTel. Jamie, Nico, thank you very much again, and I'll see you around.
Thank you.
Bye-bye.